This is the video of our sequence project. The techniques we used in our project are heuristic greedy, minimax, and Q-learning. So heuristic greedy uses the heuristic function to score each legal action, either place, remove, or trade, and then to select the highest score straight away, without considering any future possibilities. The main challenge for the heuristic greedy approach is how to score each action, based on its fast and short-term features and the rules of the game. The following place actions are given the top priorities. If placing a normal card can take heart of board, it will have the highest score, followed by forming a sequence. Two hijacks are also useful to take advantages of the game, but have slightly less score than normal cards, because two hijacks are stronger and can place anywhere. We can save them for the future. So for this example, we have both Spade King and Diamond Queen. Rather than placing Diamond Queen to create a potential sequence for the future, the agent chose to place Spade King to immediately form a sequence to get points first. From this example, we have both Heart 5 and Heart Ace. Rather than placing Heart Ace to form a potential sequence in the future, the agent chose to place Heart 5 because it is in the heart of board, which has a higher chance of winning the game. Two main advantages of heuristic greedy are fast and time-efficient decision-making, and strong early and mid-game performance, because the agent only executes the optimal action in the current round, without any expansion and prediction of the future. Therefore, the agent can evaluate all legal actions very quickly within the strict response time and execute the best one, and can establish a solid foundation in the early and middle stage of the game, and have more advantages than the opponent.
I'll quickly walk through the key design choices for the Minimax agent. First, our agent's state representation includes a 4-chip grid, each player's hand, the number of completed sequences, and the dynamic game phase. When evaluating an action, it scores the current situation using a large number of different things, which is pretty similar to a human player. One major implementation is our dynamic feature weighting. Here are all the weightings for different features in different states. In the opening phase, as shown in the picture, when there are fewer than 20 chips, center control and flexibility are most important. As the game moves into the middle and end phases, we shift the emphasis towards sequence completion and threat management. To search deeper, we rely on advanced action ordering. We use a history table which remembers moves. Killer moves are tracked at each search steps, and we try it earlier again next time. We also use a principal variation table to always search our best known line first. And we have heuristics that prioritize instant wins or threat blocks right away. Of course, there are trade-offs. Because we use fixed rules and numbers, the agent sometimes miss unusual tricks and sneaky moves that hasn't seen before. That's why going forward, we want to try out reinforcement learning so the agent can actually learn from experience and get even better.
I will briefly introduce the core logic of my Q-learning agent. The agent updates its strategy using the standard Q-learning formula on the slide. Reward plus gamma times the maximum Q value of the next state minus the current Q value. Each turn it first checks for the immediately wins or blocks. These are always top priority. If not, it picks an action using epsilon greedy approach, choosing either a high Q move or a fast heuristic. Key parameters are on slide. Central control is rewarded by 1000 point, jack card get plus 100. Q-learning rate allows gradually adjust feature weight without causing times out. The agent is capable of occupying the heart of the board, which works well. However, one main weakness is that it does not recognize 3 plus 1 nor 2 plus 2 threats early enough. This is because of the Q-learning update mainly uses final rewards from wins and loss, not from blocking potential threats. If the agent does not lose right after missing a defensive move, it receives little negative feedback. As a result, the agent is not encouraged to remove risky threats in advance.
These are two tables for approaches comparison. The first one is for 10 games and the second one is for 50 games. From those tables, we can see that heuristic greedy has the highest win rates, which perform the best, so we chose this approach as the main technique for the agent. And that's the end of the video. Thank you.